Just a quick note on the sound. I'm gonna try today not wearing the lapel mic that I was. I think it's giving me audio problems on the recording. So I will either speak into the podium mic or just speak real loud. I hope that works. If I'm roaming around, I'll just try talking loud and see if that. I've never had audio problems with this recording microphone before. It's only happened in this classroom, and it's only happened when I've had that other wireless mic on. So I admit I'm not a scientist, but we'll try to do some science on this and see if this recording works. Then I'll have to continue with this for the rest of the semester. So if at any point you have trouble hearing me, please let me know either during class or after class, and we can adjust appropriately. Okay? Okay. So, couple things just off the bat. I want to point this out about the symbolization questions because I got this from a few people. Sometimes Logic 2010 tells you that you've given not the correct answer, but a correct equivalent. And people are anxious about this. They say, well, why isn't it just correct? Why is it merely correct equivalent? I want to reassure you that correct equivalent is exactly 100% as good as correct. So the thing is that they've manually programmed in these answers. So Logic 2010 does not just know what the correct symbolizations are. Some human being has manually programmed the answers in, and there's one that they thought of first, there's one they had in mind, and then there's a bunch of others that are logically equivalent and exactly as good. So the one that says correct is just the one that they thought of first. The one that says correct equivalent is something that they think is logically equivalent to that. But for your purposes, getting either is exactly as good as getting the other. Okay, so there's no reason why you should keep going to get correct once you've got correct equivalent. They are worth the same number of points on the test. They are worth the same number of points on the exercises. They are logically equivalent, so you get exactly as much understanding out of it as having correct if you get correct equivalent. Okay? So if you see correct equivalent, congratulate yourself, you did it right. You did it 100% right. Okay? Okay. So the main business today is going to be to start on derivations. I want to really quickly, before we do that, however, I want to really quickly just do one or two symbolizations so that you've got those sort of in a skill-based kind of way to demonstrate exactly what, for example, what these things are going to look like on the test. So just so that you know what sort of task you're going to be faced with, this is exactly what they'll look like on the test. So I'll give you a sentence, and then I'll give you a symbolization scheme. The symbolization scheme is the thing. W, class will be held. S, snowing. There'll probably be some typos. Apologize. It is snowing. There we go. Okay, so when you're dealing with these on the test, I'll just quickly do these, like one or two examples so you can, and talk through how I'm solving these. So, okay, this is actually the first question from the first test last semester. So this is exactly like what you're going to face because it is exactly what students last semester faced. This is a relatively easy one though, right? Class will not be held if it is snowing. Now, despite the fact that it's relatively easy, there's a procedure that you should follow of trying to parse these sentences down. Before you start trying to apply these things, before you try to jump to the conclusion, I recommend that you try to break the sentence down into its parts. So, class will not be held if it is snowing. So I think these are like the major parts. So there's this big part, and then there's this big part, right? So something, class will not be held if it is snowing. So you know that those are the two large parts. So for class will be held is W. So you know that this is going to be class will not be held. You know this is going to be not W. Okay. And it is snowing. You know that's going to be S. Now it's just a matter of getting S and not W in the right order. So the rule that I gave you last time was, of course, whatever comes after if, whatever comes directly after if is the antecedent. The antecedent, so it's the first part of the sentence. So that means S is the antecedent of this conditional. If S, then not W. Yeah? Any questions about that one? Okay, let's do a harder one. Identical. Okay. This one we have to do some work to parse it into its parts. So if Veronica doesn't leave, if William doesn't, then Yolanda won't. Horrible sentence. It's a terrible writing. Don't ever write like this. But this is the kind of thing that I will impose on you on the test. Okay, so again, reading that, it's confusing to read, and it's hard to keep all of the parts in your head at once. So what we're basically going to be straining against, I mean, we're not like pushing the limits of cognition just yet, but as we do more and more complicated symbolization questions, what you're going to be straining against is the limits of your working memory, right? It's hard to keep all of the parts all arranged in your head all at once. That's why we parse these things into parts. All right, now recall the fact that commas are very important information. Commas indicate how to separate the sentence into parts. So we've got a big separation there. So there's this chunk, and then there's that chunk. Okay, so deal with it chunk by chunk, and then you won't get overwhelmed. So if Veronica doesn't leave if William doesn't, then Yolanda won't. Okay, so we've got an if-then statement. So if this whole thing, then Yolanda won't. Yolanda won't what? Sometimes you'll have to infer the complete meaning of the parts from the rest of the sentence. Yolanda won't what? Leave. Right. So that's not why. Okay. So we know that this part says not why. We know that it's going to be an if something, then this. So basically we know we can rough in the structure of the sentence already, right? So we know that there's going to be if this whole thing, then not why, right? And once again, whatever comes right after if is the antecedent, and then whatever's left over is the consequent. Okay, so now we just deal with the chunks the same way we dealt with the whole thing. We're going to chunk it into its smallest parts and deal with the parts individually. So just read out this chunk. Ignoring the if, what does this part say? Because this if is connected to this then. So this if says if blah, 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 then blah, blah, blah. So just deal with the inside. So Veronica doesn't leave if William doesn't. Okay, so Veronica will leave is V, so we know that this is not V. William will leave, so we know that this is not W. So we know there's going to be a not V, we know there's going to be a not W, and now it's just a matter of saying Veronica doesn't leave if William doesn't. Well, what order are these in? Once again, whatever comes right after if is the antecedent. So William doesn't, so not W comes right after if. So we know that not W is the antecedent. We know it's a conditional. So if not W, then not V, then not Y. Okay? And we didn't get overwhelmed and we didn't get confused because what we did was start from asking ourselves, what's the largest chunks of this sentence? What are the major parts? And then just dealing with those parts individually, one by one, breaking it down until you've got the most simple bits that you can identify. Okay? I'm going to do one more. Okay, let's do one more. Okay. William will leave only if Veronica leaves, then so will Yolanda. Whew, please don't ever write like this. Okay. Once again, we're just looking at this sentence and using our ability to read and understand sentences in order to figure out what the parts of the sentence are. So, William will leave only if something. So, William will leave only if blank. If Veronica leaves, then so will Yolanda. Okay. So, we know that William will leave is W. That's on the screen, yeah. So William will leave only if Veronica leaves, then so will Yolanda. So if V, then Y. And now it's just a matter of getting these into their parts. So This is the major connective of the sentence, the only if. William will leave only if this whole thing, right? So what's our rule? What comes right after only if? The consequent, just the opposite of if, right? The consequent comes right after only if. That means that this is the antecedent. So W, then this whole thing. If Veronica leaves, then so will Yolanda. So if V, then Y. Okay? Questions about this? That's the last one I'm going to do. So if you've got any questions about symbolization, I mean, that should be enough to take you through the exercises for this week. Things to keep in mind, the rules about what to do with if and what to do with only if. Things to keep in mind include paying attention to the commas and the strategy stuff that we just talked about starting with chunking the sentence into its largest parts and then taking those largest parts apart into their parts and so on and so forth. Deal with it one bit at a time. Just focus on the part that you're dealing with at that time and you won't get overwhelmed. Yeah? Okay, so it's a good question. The question was, does this whole thing need to be in brackets? And the answer is no. So if we put it in brackets, that would make it official notation. I am not going to require official notation on symbolization or derivations for the test. So informal notation is okay for all of your examination stuff, all right? You do need to offer us well-formed sentences. You cannot offer us malformed, non-symbolic sentences. But because there's no brackets, it's still okay. Right. So, derivations. This is like symbolization and derivation make up the bulk of the work that you're going to do for the rest of this class. So this is the next major skill that we're going to do. We'll do at the end of this unit, just before the first test, we'll do truth tables, which are a method for proving the opposite. If you want to prove that the argument is invalid, you can use truth tables. But if you want to prove that an argument is valid, we're going to use derivations. Derivations test the arguments that we're looking at. So recall that logic is largely about truth preservation. This is what we're interested in. Yeah.
But I think truth table is sufficient to prove that an argument is valid.
That's right. So the comment is truth tables are sufficient to prove that an argument is valid. They are, but you will see very quickly that arguments that are of a certain level of complexity are torturously difficult to build a truth table for. So you can prove that an argument is valid using a truth table, but you better not try to do one with more than like a few variable names in it because they get really messily complex and incredibly tedious. So it's a matter of practical fact that derivations are far better for proving validity than truth tables for anything but the simplest possible arguments.
Yeah, but why you emphasize here that it's a method from proving an argument is invalid?
Why did I emphasize it?
Yeah.
Well, to contrast it with derivations.
Okay.
That it's a method for proving arguments are invalid does not exclude the fact that it's a method for proving arguments are valid as well. Okay. No problem. Good. So, truth preservation is the name of the game. Truth preservation is what we're all about in derivations. We want to reason in such a way that if the premises we get are true, then the conclusion is guaranteed to be true as well. So we preserve the truth coming into the argument to the end, to the conclusion. And what we have, so the main tool that we're going to use to do this are our rules. So we've got a bunch of rules of inference that are certified truth-preserving rules. These are rules that are guaranteed to, if you give them the right sort of inputs, they will give you true outputs. So if you give these rules true inputs, they will give you true outputs. And we can guarantee that that's the case. Using these, so our derivations are going to use these rules and only these rules to get us from premise to conclusion. And if you can do that, then what you've shown is, if those premises are true, the conclusion must be true as well. Okay, so here are the rules. We're going to start slow. We're going to have 3 rules to start with. Sorry, 4 rules. We got 4 rules to start with. There's a famous joke in logic. I'm sorry, I'm going to impose it on you. Professor's standing in front of the class and says, you know, it's just a matter of fact that in all languages, double negation is equivalent to saying the truth of the thing. The student goes, yeah. All right. Okay. That's okay. I'm amazed that it got any kind of laugh at all. All right. Okay, so double negation should be fairly straightforward. It's pretty clear what's going on there, right? If you have P, you can get not P. If you've got not P, you can get P. No problem, yeah? Repetition, even simpler. If you've got P, you can get P. Okay. That's not relevant to you yet. That won't be a relevant rule until we start doing some more complex derivation stuff. So I'll show you how that could put, like right now that should strike you as a completely useless rule. It does have uses, and I'll show you not this class, but in a later class. Okay. So those are super easy. Here are some that are not completely super easy, but are nonetheless hopefully fairly straightforward. These are modus ponens and modus tollens. Those are Latin names that you actually will have to learn those Latin names. Okay, so modus ponens. The first 2 things are the premises. They are the input to the rule. So if you have those first 2 things as input, if P then Q, and P, you can get Q. Okay. Modus tollens, slightly more tricky. If you've got if P then Q and you have not Q, you can get not P. Okay, so I hope those strike you as reasonably intuitive. Let me just try to make them extra super intuitive with this stuff that we talked about last time about conditionals and how conditionals work. So the conditional if P then Q says the following. All of the P cases are contained within the Q cases, right? So if you have a case where P is true, it must be contained within the sphere of cases where Q is true, right? That means that if you're in the P region, you're guaranteed to be in the Q region. Something like that. These are spatial metaphors for something that's not really spatial, but you get the idea, yeah? So the fact, if you have if P then Q, if you have the conditional if P then Q, and you have P, then you're guaranteed that Q is true. Okay. And you can also see why a very common fallacy that is an incorrect inference is incorrect here. So you might say if P then Q, and if you had Q, people try to infer P. That's called affirming the consequent. And that is incorrect. And you can see from this diagram why that's incorrect. So just because you're in the Q region doesn't guarantee that you're in the P region, right? There's lots of parts of that Q circle that are not inside the P circle, right? Okay. So if P then Q, if you've got P, then you've got Q. This is our basic, one of our most basic rules in our system, one of our most basic rules of inference. Modus tollens, here is just the intuitive version again. So if P then Q, if you've got that you're not in the Q region. So if P then Q, once again, says anything that's in the P region is definitely in the Q region. Well, if you know that you're not even in the Q region, then you're guaranteed that you're not in the P region, right? Yeah?
I think this can be illustrated by an example. If you're a Canadian, you must be a human.
Yep.
Whereas if you're a human, you're not guaranteed to be a Canadian.
Good.
So
Yep.
you can only infer from small to big.
Yeah, exactly.
Not opposite.
Good, thank you. Yeah. Okay. So hopefully those rules are fairly intuitively obvious. If these still don't strike you as intuitively obvious, there are some exercises in the textbook that you can use to convince yourself of these. And you should, so these are not just knowledge that you need to have. These are going to be skills that you're going to need to be able to deploy in the activity of doing derivations. So having an intuitive understanding at this point would be very, very helpful. Like you want to have this as just a kind of automatized thing that you can do rather than a thing that you know. Like memorizing this is not going to help you. You need to internalize it as a skill. Okay. And the way to do that is basically practice a whole bunch of derivations, which Good news, you are going to do. Hooray. Okay, so these rules don't just apply to atomic sentences. They don't just apply to P's and Q's. They also apply to more complex molecular sentences. So here's another valid application of the rule MODUS TOLLENS. This is a valid application of MODUS TOLLENS. So I've got this complex first sentence. It's not the case that, sorry, if, it's not the case that if not P then Q, then if R then not S. Kind of inference you'd make every day, I'm sure. And then if you have the negation of the consequent. So no matter how complex the conditional is, so the first line there is a reasonably complex conditional. It's got a bunch of parts. But the whole sentence, the major connective of that sentence is still the conditional. Right? So that whole sentence is a conditional with an antecedent and a consequent. And no matter how complex the consequent is, if you've got the negation of the whole consequent, then you can apply the rule MODUS TOLLENS and get the negation of the antecedent. Yeah? Sorry? Yes. So, yes. I'll present you a rule about this, but yes, you will be able to do that. Yeah. Well, in logic? Well, okay, so there's a great number of different logical systems that allow you to do a great number of different things. So as a house rule, okay, maybe we'll do this now. So in this class, these are going to be our rules about this. This is a good question. We're skipping ahead a little bit to talk about this, but in this class, these are going to be our rules. And I'm kind of imposing these as general rules that will apply for the rest of the class. You must provide an exact match as input to the rule that uses negations. So if you have something that requires, so I'll show you examples of this, but if a rule that involves negations produces a double negation as the major connective, then you can give yourself the unnegated version. I'll allow you to give yourself the unnegated version. So let me show you examples of those that seem a little abstract. So inputs must match exactly. So the thing on the left is fine because what we've done in the thing on the left is cited line 1 and line 2, and that dn there says double negation. So I've double negated Q to give us not Q. Not Q is the negation of not Q, meaning that we can use MODUS TOLLENS. Okay, so the input has to match exactly. You have to include that dn, that double negation sign, or that double negation as a rule. You're not allowed to do the thing on the right. If R, then not Q, and then Q, and just give yourself R. Right? It should be, sorry, that should be not R. Yeah, 3 should be not R, but you get the idea. Or do you? It's wrong anyway. I hear confused murmuring. Maybe it would be better if we started trying derivations before I introduced these rules. Yeah? Okay, sorry, I saw a hand.
Yeah, I was going to ask, is that only if you omit the double negation on Q, like both signs? If you were to leave it, then you wouldn't have to put dn in the justification, right?
You do need to add dn in the justification.
Even if you include the double negation sign in front of Q?
Sorry, I don't think I understand your question.
Okay,
I think she means like in line 2 you put negation, Q, and then you go to line 3.
yeah.
Oh, I see what you mean. Okay, so if I said instead of that, if line 2 instead was negation, then would I still need this dn? That's right. So you would not. So that's fine too. That's fine too. Okay, I think this is jumping ahead too much. I think we should show you the mechanics of derivations, and then I'll show you this again. Okay? Okay. One more question? Did I see another hand? Okay. So Okay. Yeah, sorry, I should have just put that off and answered it after. It's a very good question, though. Okay, so a derivation starts from the following. It starts from some set of premises which are given. So every derivation that you do in the class, you'll have some set of derivations. Some set of premises. And those premises lead, hopefully, by application of one or more rules to the conclusion. And if you've done that, you've finished your derivation. So the derivation just starts off from the premises, gets to the conclusion, and then you're done. Okay, so here's an argument. This is straight from the textbook. The textbook published in 2013, when it was super obvious that nobody named Trump would ever be president. Okay, if Polk was president, then if Whitney was president, then so was Trump. Premise 1. Polk wasn't a president only if Trump was the president. Premise 3. Trump wasn't a president, obviously. Therefore, Whitney wasn't a president. Okay, so looking at that, it may or may not be obvious whether those premises guarantee the truth of the conclusion. So the first 3 lines are things that you're given. You've been given those as things that are assumed the truth of. And now your task is to work out whether the conclusion is guaranteed by those premises. So now how do we do that? Well, you're not going to do it in the natural language. You're going to symbolize it first. So here's a symbolization of those premises and the conclusion, where P is Polk as president, W is Whitney as president, and T is Trump as president. Okay? Okay. So now we're going to try to do a derivation that leads from those premises to that conclusion. And here's the basic steps. You're going to write what's called a show line, the thing to be shown. And the show lines are the only part of a derivation that you don't have to justify. Every other step, so each step is a line, every other step must be justified somehow. And you just keep showing things until you get to the conclusion. And at that point, you can cancel the show line, and I'll tell you more about why you do that when we get to subderivations. But let me show you this as an example, because that probably didn't make a lot of sense to you. If you've never done this stuff before, what I just said to you probably didn't make a heck of a lot of sense. So let's do this. All right, so those are the premises that I just showed you, and this is what it's going to look like. On the test, this is what it's going to look like. I'm going to give you premise, 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 therefore, conclusion. You may or may not want to label these things for yourself, P1, P2, P3. Okay, so every derivation that we do, there's a kind of ritual about derivations, okay? Every derivation that we do is going to start with the following. Sorry. It's going to start with a show line, and we're going to number each of our lines. So line 1, we're going to show that not W is the case. Okay, so that's our goal. The show line is the thing we want to show. We haven't got it yet. We don't have it. We can't use the show line as a basis for inferring anything else. What we can do is try to build an argument for not W from these premises. Okay, so the show line, basically imagine there's another column right here of justifications for each line. The show line you don't have to justify. It's just you stating your goal. Okay. Now, by application of the rules that I just described, we're going to apply those rules to these premises, and by doing so, we're going to derive the conclusion. So, here's a thing that we can do. We can apply MODUS tollens here. So this is the negation of this consequent. So if you have a conditional, and you have a negation of that conditional, you can get the negation of the antecedent. That was MODUS tollens. So we're going to justify this by saying premise 2 and premise 3 MODUS tollens. And that's going to give us not P. Yeah? Okay, and the question before was, am I allowed to just give myself P from that? And yes, you will be allowed to do that, but let's just do this step by step for now. So Line 2, so I cited the premises there, right? So I said P2, P3. Once you have an available line, once you have a line that is not a show line, we'll talk more about what makes a line available or not. Once you have a line available, you can cite it as part of your justification. So I'm going to say here line 2, double negation. And that'll give me P. Great. Line 4. Okay. So now that I've got P, so I've used premise 2, I've used premise 3. I could use them again, there's no problem there, but just strategy-wise, you usually want to see if you haven't used anything yet. So I've got P, and I've got if P, then this thing. So great, I'm going to say line 3 and premise 1. Modus ponens. And that'll give me if W, then T. Sorry, I've been inconsistent about labeling these things. I said P2 and P3 or PR1. It's okay if you just say P1, but Logic 2010 is going to make you say PR1, so it's probably better to stick with that. Okay, so now we've got if W, then T. We've also got not T, so we can do the same thing. We're going to say line 4, premise 3. Premise 3, modus tollens, giving us not W. Great. We're going to say on line 5, I did what's called a direct derivation. Direct derivation, that will be when we talk about, there's at least 2 other types of derivations we'll do in the first half of this course. Indirect derivations and conditional derivations. Don't worry about that yet, but right now, this is how we close off the thing. We say, on line 5, I derived the thing that I was trying to show, and then we cancel out this show line and draw a box around it. We box and cancel. And that's kind of the ritualistic ending to doing a derivation. Okay? Yeah?
I was wondering, can we simplify this by skipping this line 2?
Yeah, I did say that we could do that. Yeah.
Oh, okay, sorry.
Yeah.
I didn't get it.
Yeah. Okay. So that was your first ever, if you've never taken this course before or something like it, derivation. Congratulations, you survived it. Okay, so any questions? Any other questions? Yeah. DD stands for direct derivation. It's just sort of saying we got the thing that we were trying to show.
So if it's not C.
Sorry?
If we're not saying which is derivation.
We're going to say, I want to show it's not the case that if W, then Z. Okay, and I'll just label these for myself. You don't have to do that. This is not part of the answer to the question, but just so that we don't get confused. So, we'll talk more strategies soon. I'll describe to you how I decide which moves to make shortly, but hopefully some of these moves will be obvious to you. So given premise 4, double negation, we can get P. And given line 2, given P and premise 3, so PR3, modus ponens, we can get X. Hey, that sounds good. Okay? So now X is the unnegated version of this. So this is where what I was saying about negated, doing it, the inputs have to match exactly. You do need to say line 3 double negation here to get not X. And then you can use line 4, premise 2, modus tollens. So I've got X. I use that to build the negated version of this. And then if you've got the negation of the consequent, of a conditional. So this is the major connective is a conditional. You've got the negation of the consequent of a conditional. You get the negation of the antecedent. So I don't get if Z then W. I get if not, sorry, it's not the case that if Z then W. And you've got to be really careful here. So do not do the following. Don't do this. If not Z, then W. So that's not the negation of this sentence. Okay? Not Z is that's adding a negation to Z, not adding a negation to this whole thing. So you need the brackets there. Okay? Okay. Now, what can we do with if not Z, then W? Well, premise 1 here, that's the negation of this consequent. So we can say line 5, premise 1, modus tollens, giving us, it's not the case that if W, then Z. And that's the thing we were looking for. That's the thing we were trying to get. So line 7, we can say that on line 6, we did a direct derivation. Cancel this show line and box it off. Yeah?
Is it always necessary to say on line 6 you did direct derivation of this field like that?
No, you do need to do what's called closing off the derivation somehow. So you do need to say line 6 direct derivation. We could have, if you want to save yourself a line, you could say on line 6 direct derivation, and then you would not have a line 7. That's okay. When we're starting off, I'd rather not compress too much. I'd like to sort of like let everything breathe. But that's the only thing. You do need to have this direct derivation. You do need to tell me how you finished off the derivation. Yeah? No. So yeah, well, I'll explain repetition. Repetition is not going to be relevant until we do subderivations, which are derivations within derivations. So those are different rules. Yeah. Okay. So is the basic activity clear here? Like what we're doing? You're given, so these are things that you have. You have these. These are assets. You get to use these. You use them by applying rules to them. So far, we've got these 4 rules. So given these 4 rules, you apply those rules to take what you've got, your assets, and pull things out of them. And then once you've pulled something out of it, those lines become assets that you can then apply the rules to. Yeah?
Does it matter how many lines we use? Let's say we get the answer
Yeah.
and more lines than necessary.
Yeah, good question. So does it matter how many lines you get? No. There's no bonus points for, like, once you get to be a fancy logician, you get like, oh, it's such an elegant proof. That's not where we're at. So the rule is going to be, if you get from premises to conclusions following all the rules, you get all the marks. Does not matter how many, doesn't matter if you have useless lines, doesn't matter if you repeat a line, none of those are going to be deductions on your marks. If you get from premise to conclusion following all the rules, you get all the marks. Okay, yeah?
Will every premise always have a period at the end of it?
Yeah, they'll always have periods after, yeah. Okay. Okay, we got 6 minutes left. Using those 6 minutes, I'll show you the controls for derivations on Logic 2010. So, we're going to select for ourselves a derivation to do. So I'm going to start with the very, very first one. Okay, so the keyword controls are as follows. Enter to start a new line. Okay? Now, you're going to write your show line because every derivation starts with a show line. You could, on here, say show, not Q. Okay? That gets to be kind of tedious. Like not Q is not all that hard to write. That gets to be a little tedious when the things get longer. So I'm going to press Alt-Delete, start a new line. You can just say show conclusion here. and it'll generate the show line for you automatically. Don't write that on your test. Please don't write that on your test. That's not a move in the derivation. This is just a command in Logic 2010 to get it to generate the relevant show line for you, okay? Okay, so now we're going to use our lines. So this is the really nice thing about doing derivations in Logic 2010. You just tell it which rule you want to use, and it tells you what the output of that rule is. It's kind of doing half the work for you. On the test, you're going to have to figure out what the output is, but so long as you give it a valid rule and some valid inputs, it tells you what the output is. So for example, I say premise 1, premise 2, MODUS TOLLENS, MT for MODUS TOLLENS, and it tells me that I got not Q. Hooray. Okay, and that's the thing that I was trying to derive. So I say on line 2, direct derivation, and then it does the boxing and canceling. And then I say check, check that it's correct. And then I say save, I say submit, and I go through all that. Okay, let's do one more. Okay. So, press enter to start a new line, show conclusion, or show conc if you want. All right. Now I just start applying my rules. You can, if you want, you can right-click here to give yourself this drop-down menu. On Macs, that's control-click. You can just use this to, for example, say premise 1 space premise 3 space. And then these are the rules that you have available. MODUS, TOLLENS, just enter. Oh, wait, no, it was MODUS TOLLENS, wasn't it? I find that incredibly tedious to do, but so premise 1, premise 3, MODUS TOLLENS, good. Now we've got line 2. So watch what happens when you try to do the unnegated version. So line 2, premise 2, MODUS TOLLENS, it will say that that's not acceptable. What it wants is the following. It wants line 2 double negation. Now we can say line 3, premise 2, MODUS TOLLENS to get not R. And that's the thing that we're trying to do. So line 4, direct derivation. Okay, so there's lots of more little bells and whistles in here. There's lots of little controls that are useful. Alt delete deletes a line, super helpful. There's lots of things that you can use to generate show lines quickly and easily. But those are the basic controls. That should be enough to get you through this exercise. Okay, thanks for sticking in, everyone.